In today's class, we are going to see the test of significance for difference of two means. So here in the previous class, we saw the test of significance for a single mean, that is a population mean and a sample mean was given. Here, what does difference of two means mean actually is? You will be given means of two samples. Based on comparison, you will give a conclusion. Okay, so we'll go to the problem. A company wants to test two different versions of its AI based chatbot, version A and version B, to see which one performs better in terms of average customer satisfaction. So, this average customer satisfaction is your mean. Average, it's talking about your mean in terms of average customer satisfaction scores. They collect data from 400 users for each version. So you are considering version 1 and version 2, and for each version the sample, the data, collected data is 400, that is n1 is 400 and n2 is also 400. So here your n value is greater than 30. So it is a test for large sample. Okay, the next one, the average satisfaction score for version A is 8.4. The average satisfaction, that is your x1 bar, it is talking about your samples average. So x1 is 8.4 and your standard deviation is 1.1. Likewise, the average satisfaction for version B, so for your x2 bar it is 8.1 and the standard deviation s2 is equal to 1.3. So what you are going to test is the hypothesis that there is no significant difference between the two versions. So your null hypothesis is directly given. So you can directly write there is no significant difference between the two versions. Or you can write x1 bar is equal to x2 bar. Okay, that is how you define your H0. Now coming to your H1, how do you define your H1 is the alternative of your null hypothesis. That is, you write there is a significant difference. Okay, or else you can write it as x1 bar is not equal to x2 bar. So when you have a not equal to sign in between, it is called as two-tailed test. Okay, now coming to step 2, it is told already in the question the level, significance level is 5%. So the level of significance is 5%. So for a two-tailed test, for 5% level of significance, the table value is 1.96. Okay, so now coming to our problem, we are already gathered some data from the question. We'll use that to solve the problem. Okay. Okay, so now from the question, we already know what is n1, n2, x1 and x2 bar. Everything will substitute in the formula. So your x1 bar is 8.4 minus 8.1 divided by square root of, here you are given only the sample standard deviation. So the same will be for your population in case since it is not given. So here your sigma 1 square will be 1.1 square by 400 plus 1.3 by 31.3 square by 400. So once you solve this, the answer which you would get, it would be equal to 3.52. So this would be your calculated value. So now step 4, you are going to check with the table value and the calculated value. Table value was 1.96 and the calculated value was 3.52. So you are going to check if 1.96 is greater. So it is not greater. So it is obvious in this case we reject H0 and accept H1. That is, you say there is a significant difference. That's all. Okay. So here, reading the question, you have to check whether the problem is of proportion or mean. Once that is identified, you have to check whether the mean or proportion is between two samples or between a population and a sample, and pick any one, the correct one of the 4 formulas. Just substitute, compare with the table value. Before that, write your hypothesis and it's over. Okay.